We're going to be doing the second long problem for the practice exam. Um, Here we go. So I'm going to go ahead and read it. In the coordinate system shown in the figure below, not drawn to scale, there are 2 point charges along the x-axis with their information on the charges and coordinates listed in the following table. A field point A is at xa equals 1 centimeter. I'm going to go ahead and just draw that over here. Actually, I have it right there. First thing, so I'm just not going to go ahead and draw it. Just reference this over here. So find the electric potential at point A. So go ahead and draw this in. One, we're trying to find VA. Not Veteran Affairs, but VA. So we need to understand that VA is equal to, actually, you know what? Let's type this. Hope you guys can understand. VA is equal to V1A plus V2A. But V1A is going to be equal to KQ1 over XA minus X1. And you can go ahead and calculate that out. But after you calculate that out, and you insert all of your different variables, you come out to 5.993 times 10 to the 5th volts. Going ahead and inserting all of the different variables that we have from over here into over there. We also need to find V2A, which is also characterized similarly as KQ2 over, it's different here because we're trying to find potential, and we don't know what XA is. So actually we do know what XA is, but we're just going to be doing X2 minus XA. When you calculate that out, V2A comes out to be 4.495 times 10 to the 6th volts. So we end up adding these two together. So V1A plus V2A gets us VA equals 5.094 times 10 to the 6th volts. That's for part A. I don't understand why I did this, but A. B, we need to find the electric field at point A with both direction and magnitude. So we need to find EA. And how do we do this? It's going to be similar in that electric field works similar to electric potential in that, I'm just going to go ahead and type it out here. E1A is going to be equal to, EA is equal to E1A plus E2A. And so E1A is going to be equal to K times the absolute value of Q1, right? And then we're going to have that over XA, but this is in parentheses, XA minus x1 squared. And when we put in all of our variables here, E1A is equal to 1.998 times 10 to the which power is this? Oh, I forgot to write down the power. It's 2 of something. I'm going to go ahead and calculate this here. Shoot. Sorry, guys. I believe this is 10 to the 7th. I may be wrong, but I believe it's 10 to the 7th here. Oh, I forgot to actually add directions as well. Shoot, I'm sorry about this, guys. This E1A is going to be positive here because it'll be coming from positive. It's a positive 2A, so that'll be positive. But then E2A will be negative. So I'll make sure to put positive here for our first term, and it's negative for this term. E2A equals K times the absolute value of Q2. This is over x2 minus xa. Right, because we go from x2 to xa, that's the distance, and that's squared. And when we go ahead and put this in, we get E2a equals negative 4 point, sorry, I take that back. Comes out to, I'm looking at a big sheet of paper here, 4.495 times 10 to the third. Now we have to find EA. So EA is going to be E1A adding, because we're going to add these two energies total. But what we have is a negative for our E2A, so a negative E2A. EA then comes out to negative 4.295 times 10 to the 8th newtons per coulomb. So again, I'm going to go ahead and say this all again. These are all of our derivations here. And just to save space, I've gone ahead and just calculated them out here for you. So then, once we have our different variables, we're going to add E2A, which is a negative, to E1A and get EA, newtons per coulomb. Make sense? Should. This comes out to be in the negative direction. For C, we're placing a point charge. And so if we place a charge at Q3 equals negative 15 microcoulombs at point A, how large is the force exerted on Q3? Both directions of magnitude are required. Use the E field from B to compute the force. So we need to understand that E, remember this equation, E, it's a vector, is equal to F over Q0. And then we do a little bit more here. F equals E times Q. Sorry, that's not Q0, that's just Q. You know what, I'm not good at this drawing part. I'm just gonna go ahead and type it out. So when you take this, you can understand that you can go ahead and make it so you find F here. We have all these different variables. So our EA, we need to find force. We're looking for force here. So force will equal what we have from EA. So we're going to go ahead and insert that right here. So since this is much smaller, I'll just go ahead and do a calculation step as well. Times Q, and Q is negative 15 from our from the problem for part C. Actually, I said I'd do a derivation step. I'm sorry, I'm just not getting this done right now, apparently. Yeah, so that'll be Q3. F will equal what we went ahead and got there for EA in part B. So the negative 4.295 times 10 to the 8th. Multiply that by Q3, which here is 15 times 10 to the negative 6th. And then F, after calculating that out, comes out to 6.443 times 10 to the 3rd newtons, which is what equals F3. And this is in the positive x direction. All right, thanks for sitting through with me, guys. Sorry I had a little hiccup there, but I'm going to go ahead and use this as my final recording.